Every year, tax slabs change, and every year, payroll formulas have to be updated. One wrong formula can affect an entire payroll. But what if you never had to rewrite those formulas again? What if you only updated one table and every tax calculation updated automatically? Today, you will build a professional payroll model using Excel tables, XLOOKUP, and let function. Let's build it. Let's begin by creating the tax slab table. Every payroll calculation depends on these tax rules, so instead of hard coding them inside our formulas, we will keep them in a separate table. This makes the workbook much easier to maintain because whenever the government revises the tax slabs, we will only update this table, while the formulas remain exactly the same. Now I will convert this range into an Excel table and name it tax slabs. Excel tables provide structured references, making formulas easier to read and automatically expanding whenever new tax bands are added. Now let's calculate the employee's income tax. The first step is identifying the correct tax band based on the employee's taxable income. I will use XLOOKUP with an approximate match, allowing Excel to find the highest income slab that does not exceed the employee's taxable income. Once we know the correct tax band, retrieving the remaining information becomes very straightforward. Notice that I'm using a match mode of -1. Unlike an exact match, this tells XLOOKUP to return the largest tax slab that is less than or equal to the employee's taxable income. Since salaries rarely match the beginning of a tax band exactly, this allows Excel to identify the correct tax slab automatically for every employee. Next, I will use another XLOOKUP to return the fixed tax associated with that tax band. Now I will retrieve the applicable tax rate from the same table. Finally, I will calculate the excess income above the beginning of the tax band. This is the portion of income on which percentage tax will be applied. I am adding 1 to the calculation of excess income because the beginning of each tax band is inclusive. Without it, the first taxable rupee would be excluded from the calculation, resulting in a 1 rupee understatement of tax. Now we have everything we need: the fixed tax, the applicable tax rate, and the excess income. The final income tax is simply the fixed tax plus the tax calculated on the excess income. Our calculation works perfectly, but we can make this solution even better. Notice that the logic of our calculation is currently spread across several formulas. While this approach is easy to follow, it also means multiple lookups, additional helper columns, and business logic scattered across the worksheet. This is exactly where the let function becomes valuable. The let function allows us to store intermediate calculations, assign them meaningful names, and reuse those values throughout the formula instead of calculating the same thing repeatedly. One of the biggest advantages of let is that it lets us write Excel formulas in a structured, coding-like format. Rather than one long, difficult-to-read expression, we can organize the calculation into logical steps using descriptive variable names. You don't need any programming experience to benefit from this approach. The result is simply a formula that's much easier to read, audit, troubleshoot, and maintain. Let's build our formula. First, I will define the employee's taxable income. Next, I will store the beginning of applicable tax band. Then I will retrieve the fixed tax. Now I will retrieve the applicable tax rate. Finally, I will calculate the excess income above the beginning of the tax band. Now the final calculation simply combines these variables to determine the employee's income tax. Notice how much easier this formula is to understand. Instead of working with repeated expressions and anonymous cell references, we are working with clearly named business values. The formula now reads almost like plain English, making it easier for you or anyone else reviewing the workbook to audit and maintain in the future. Now that our let function is complete, let's put it to work. So far, we have tested the formula using a single employee. Now let's apply the same formula to the entire payroll. With just one formula, Excel calculates the income tax for every employee based on their own taxable income. There is no need to write separate formulas for different tax bands or salary ranges. For each employee, the formula automatically identifies the correct tax slab, retrieves the applicable fixed tax and tax rate, calculates the excess income, and returns the correct income tax. This is the real power of combining XLOOKUP with let function. We write the calculation once and then simply reuse it across the entire payroll. Our formula is now calculating income tax correctly for every employee in the payroll. But payroll isn't just about calculating tax correctly today. It's about making future updates as simple as possible. Tax laws change almost every year. New tax slabs are introduced, rates are revised, and fixed tax amounts are updated. Let's see how our solution handles those changes. Instead of modifying complex formulas throughout the payroll, all we need to do is update the tax slab table with the new tax rules. As soon as the tax table is updated, every employee's tax is recalculated automatically using the new rules. Notice that we did not touch the let formula at all. The formula remains exactly the same, only the business rules changed. This separation of business rules from calculation logic makes the workbook much easier to maintain, audit, and update whenever the tax law change. A well-designed Excel solution should not require you to rewrite formulas every year. It should simply adapt when the underlying business rules changes. Thank you.